This slide deals with density, specific gravity, and specific volume. Density is the mass per unit volume of a substance. For example, the density of water is 1000 kg per cubic meter, which is the same as 1 metric ton per cubic meter. Because specific volume is the inverse of density, it will have SI units of cubic meters per kilogram. Specific gravity therefore is the density of the substance, divided by 1000 kg per cubic meters, and is unitless, as the kilograms per cubic meters cancel out. A flow rate indicates how much material flows into, or out of, a process, or how much material is flowing in a pipe. Mass flow rate is the mass flowing per unit time, and is measured in kilograms per second. For example, if 10 kilograms flows into a process in every second, the mass flow rate, or m dot, is 10 kilograms per second. You get this by dividing 10 kilograms by 1 second. Volumetric flow rate is the volume flowing per unit time, and is measured in cubic meters per second. For example, if 1 cubic meter flows out of a process in every 2 seconds, the volumetric flow rate, or F, is half a cubic meter per second. You get this by dividing 1 cubic meter by 2 seconds. Consider a plug of fluid with volume V and length L that is flowing in a pipe of internal cross-section A. The volume of the plug is the cross-sectional area times the length. The plug moves, L meters, down the pipe, in T seconds. Note that L, divided by T, is the velocity of the plug of fluid. Mass and volumetric flow rate are related by the density of the flowing substance. Molar flow rate is the moles flowing per unit time, and is measured in moles per second. For example, if 3 moles flow past a point in a pipe every 4 seconds, the molar flow rate, or N dot, is 0.75 moles per second. You get this by dividing 3 moles by 4 seconds. In SI units, 1 mole is 6.022 times 10 to the power 23. One pound mole is 6.022 times 10 to the power 23 times 453.6. The molecular weight is the mass per mole, hence it is also the mass flow rate divided by the molecular flow rate. From the equation, the number of moles is the mass divided by the molecular weight. Composition is for process streams containing more than one compound. A compound is made up of two or more elements. Note that if you add up all fractions in a process stream, you should get 1. If you add up all the percentages, you should get 100%. Concentration is the mass, or moles, per unit volume. It can be used for gases, and for substances dissolved in a liquid, such as a given mass of salt in water. The units of concentration are grams per cubic meter, or moles per cubic meter. One mole of sulfuric acid per liter is 1 molar, which is written 1 m. If you consider the protons of the sulfuric acid molecule in the acid solution, you would have 2 protons per molecule of sulfuric acid. The 1 molar acid solution would therefore be 2 normal with respect to protons. This is written as 2 n. For a gas, 2 ppm of ammonia would generally mean that of a million gas molecules, 2 molecules would be ammonia. For a liquid, 2 ppm of ammonia would generally mean that if you had a million grams of liquid, this would contain 2 grams of ammonia dissolved in it.